In class, we're going to continue with the next section, okay? Rates of change in the natural and social sciences. So we're going to look at a couple of examples here. As far as the definition that is concerned, we've seen this before, okay? So first, the definition of rate of change. Remember, in general, the rate of change refers to the average rate of change of y with respect to x. Now, the instantaneous rate of change becomes the derivative function, okay? We have seen this before. And again, when we look at the graph, excuse me, we can see the average rate of change of y with respect to x represents the slope of a secant line, PQ, okay? It represents the slope of a secant line, PQ in blue. And then the instantaneous rate of change represents the slope of a tangent line, the red line. That's the idea. So, could somebody read this example for us, please? Could somebody read the question for us, please? Anyone?
After 2 weeks, the number of people using a new rapid transit system was approximated by the formula n of t equals 6t squared plus 500t plus 8,000. At what rate was the use of the system changing with respect to time after 8 weeks?
Thank you so much, Ethan. So basically, you have one point in time which represents instantaneous. Okay, so number one, you need n prime of t. That's a very simple process, which is 12t plus 500. And then after 8 weeks, you're going to plug in number 8. That's a very simple algebra. And it gives us 596. It's important to understand, read the question and write the units, people per week. Okay, remember what's n prime if we rewrite it in the following manner. dn dt in Leibniz notation, we can easily pick up the units. I want to make sure that we understand the units. So what does it mean? The number of people that are using this transit on week 8 or after week 8 is increasing because this number is positive, increasing by this much. So the number of people using the transit is increasing at a rate of 596 people per week after or on week 8. Okay. I'm going to look at another example. Okay. Very similar to that. Could somebody read this question for us? Anyone? Anybody want to read this for us?
I can read it, Professor.
Please.
Example 2, a bacterial colony is estimated to have a population of Pt is equal to 24t plus 10 all over t squared plus 1 million t hours after the introduction of a toxin. What is the population after 1 hour?
Thank you so much, Zaina. The very first part is basic algebra, plug in number 1, and just answer it accordingly. Okay. So because it's in millions, so 17 means 17 million bacteria. Okay. Part B, we are interested in the rate and given only 1 point at time. That means instantaneous. That means differentiation. Differentiation requires the quotient rule. Okay. So you differentiate P of t using the quotient rule. The top gives you 24 times the bottom, minus the bottom gives you 2t times the top over the bottom squared. And so now you are going to simplify the numerator. This is 24 t squared plus 24 t squared plus 24 minus 48 t squared minus 20t, and you simplify, you put together like terms, you get negative 24t squared because these two add up to negative 24t squared. If you put them in descending order, minus 20t plus 24. And so now what? You plug in number 1 and you have your answer. Plug in number 1. So when you plug in number 1, it gives you negative 5. Negative 5. Why million? Because you go back here. Why bacteria per hour? Look at the concept of P prime. Maybe again I write this as dP dt, the change in population over the change in time, okay? That will help you see the result. Now, what is happening to the population? Because it's negative is decreasing. So the population is decreasing at a rate of 5 million bacteria per hour, 1 hour after the toxin is introduced, okay, class? 1 hour after the toxin is introduced. So because it's negative, you mentioned decreasing, but you keep it at number 5. I can't emphasize this enough. Positive is increasing, negative is decreasing, class, okay? All right. The distance in meters of an object from a starting point is given as follows. S of t is 2t squared minus 5t plus 40, where t is time in second. And so we want to find the velocity from 2 to 4. This is the good old velocity, the average velocity, that is the total distance over total time. So the first part is a very basic algebra, everybody. The first part is a very basic algebra, okay? So S of 4 minus S of 2 over 4 minus 2, the total distance over the total time. So we just plug in. Okay, so you plug in number 4, gives you 52. You plug in number 2, gives you 38. So subtract 38 from 52, and it's meters per second. What about the instantaneous velocity and acceleration? First, the instantaneous velocity, even if it doesn't say instantaneous, later on you see that 4 seconds, that's what it means. But what is the velocity and acceleration? Normally in physics, we refer to a differentiation. So differentiate this. This is simple differentiation. 4t minus 5. And after 4 seconds, you just plug in and you get 11 meters per second. The units for the velocity, whether it's average or instantaneous, makes no difference. Acceleration is defined as the second derivative of the position function or the first derivative of the velocity function, okay? The average rate of change of velocity with respect to time, or the instantaneous rate of change of velocity in this case with respect to time. What does it mean? Differentiate it again, and that gives you simply 4. Because 4 is constant, class, then it really makes no difference after 4 seconds or 10 seconds or anything. You got to plug in and it doesn't change anything. The units would be meters per second squared, and here's the reason. I'm going to write this as delta V, in this case dV I should write, dV over dt, which means meter per second per second. And that's why we get 4 meters per square second. Whatever we do to numbers, we do also to units. That's how it works out, class. Okay, so I hope everybody's comfortable with that. Now, when does the velocity reach 31 meters per second? Okay, the velocity, we found it to be 4t minus 5. So set it equal to 31. This is a simple algebra. Move the negative 5 becomes positive. With 31 is 36 divided by 4 is 9 seconds. This becomes 36. You divide it by 4, and the answer is 9 seconds. I hope everybody is comfortable with that. Okay. Does anybody feel like reading this for us, class? Anybody want to read the question for us, please? Okay, anyone? Suppose that the ball is dropped from a height of 450 meters above the ground. S of t is negative 4.9 t squared plus 450. What is the velocity after 5 seconds? Well, first and foremost, let's find the velocity. That means S of t. Now let's go to V of t, differentiation. Negative 4.9 times 2t. So that gives you negative 9.85, negative 9.8 t. Okay, so the first thing that you need to find is actually the order was wrong, class. So first and foremost, we get this one. First, we get this one. Negative 9.8 t. And now replace the t with 5. Gives you negative 49 meters per second. How fast is the ball traveling when it hits the ground? When it hits the ground, what is the height? The height becomes 0. Okay, so when it hits the ground, the height becomes 0. So you need to find how long it takes to hit the ground. Okay, so again, the order sadly is not the way I had it in mind. So class, my apologies. Set S of t equal to 0. That should be the first one. Set S of t equal to 0. And you solve negative 4.9 t squared plus 450 equal to 0, which means t squared is 450 over 4.9. And now you take a root, and there are two answers, plus minus. We only accept the positive answer. T is roughly 9.6. And you put that into the velocity function. You put that into this function. Negative 9.8 t. So negative 9.8 times 9.6. And it becomes negative 94.08 meter per second. Okay. Velocity is a vector. It has magnitude and direction. That's why negative towards the center of Earth. Okay. All right. Let's look at the concept when we deal with economy. Okay. So in economics, profit, obviously, as everybody remembers from, I think, algebra, we've seen it, is defined as revenue minus cost. Okay, so let's C of x, R of x, and P of x represent respectively, the total cost, revenue, and profit from the production and sale of X items. Okay. The marginal cost at X given by C prime of X. When we say marginal cost or marginal revenue or marginal profit, we mean differentiate. That's what it means. Is the approximate cost of X plus first item. Okay. Now the marginal cost is, if you can calculate C prime of X easily, you can calculate C of X plus 1 minus C of X easily. They happen to be almost the same, okay? Because delta Y, if you recall, is f of X plus delta X minus f of X. And so delta X is roughly 1. And for items production, remember delta X approaches 0. I hope everybody remembers that when we did the differentiation delta X or H. But when delta X is 1, that's small enough, and that's why the definition of a marginal cost. Same thing for the revenue class. R prime of X, what is that? Given the R function, differentiate. R of X plus 1 minus R of X gives us the revenue from the next item, so X plus first item. And same thing for the profit, which is basically R minus C. So the marginal profit at X given by P prime of X is the approximate profit for the next item, X plus first item. So again, P prime of X, R prime of X, and C prime of X are called marginal, okay? Marginal profit, marginal cost, marginal revenue, marginal cost, okay? And so that's the idea that we are working on. And of course, another way of writing it that P of X plus 1 is P of X plus P prime of X. So let's make some sense out of this by looking at a very simple example class, okay? We want to find each of the following, okay? Where cost function and revenue function are given, okay? How do we find the profit function? R minus C, R minus C. I hope this is pretty straightforward to everybody. Revenue minus cost is the profit function, R minus C. So that's a very simple algebraic step. So R minus C, you do the simplification, you put them in descending order, and the final answer becomes X cubed minus 74X squared plus 40X minus 27,490. And I hope you see why this is minus 62X squared and minus 12 is minus 74. Then 10 minus 27,500 gives you that. Okay. So what is the total cost, revenue, and profit when we have 50 units produced and sold? Just plug in. I don't, worry about that. I assume everybody can do that. Just plug in 50 for the cost, 50 for the revenue, 50 for the profit. Now, if you calculate the cost and revenue for the profit, you have two choices. Again, plug it in here or just revenue minus cost. So I'm going to assume C of 50 we plug in. Okay, everybody? R of 50 we plug in. Okay. And P of 50 we can plug in. Okay. Again, just by plugging in. Okay. Or did I? Or R of 50 minus C of 50 would be faster. So subtract 182,500 from 97,010, that gives you the same answer. So subtract the blue one from the green one. That's another way of doing that, class. Okay, so for the last part, you can do it that way. Okay. So I hope everybody's clear on that. All right, now let's find, okay, so we have the cost function, the revenue function, the profit function from the previous page. And we want to now find the marginal cost, revenue, and profit when 50 units are produced and so on. What does it mean? Okay, it means differentiate, plug in 50. Differentiate, plug in 50. Differentiate, plug in 50. Each case means differentiation. So, C prime of x, 62 times 2x, 124x, plug in 50, and it gives you the answer $6,200. Marginal cost, differentiate, plug in, differentiate, plug in. So the moment we hear marginal means differentiation. R prime, 3x squared minus 24x plus 40. Okay, now plug in what? Number 50. Plug in number 50. Plug in number 50. Plug in number 50. A simple algebra. Okay. Marginal profit. There are two ways to do that. Let's go with the long way and I'll explain the short way in a moment. P prime, 3x squared minus 74 times 2x plus 40. Now plug in number 50. And evaluate. This is the long way. What would be the short way? Class. P prime is R prime minus C prime. So all you have to do, subtract 124x from 3x squared minus 24x plus 40, you get that one. That's another. What about P prime of 50? R prime of 50 minus C prime of 50. And that means 6340 minus 6200, giving you the same answer. Again, both ways we wanted to see what's happening, and now what do they mean? Here's what I want everybody to pay attention to. So when 50 units have been made, okay, and sold, of course, the approximate cost of the next item, that means 51st unit, will be $6,200. So this C prime of 50 is the marginal cost that represents the cost of producing the next item. And the approximate revenue from the sale of the 51st unit will be $6,340. This is how much we make, okay, as the revenue for selling the next item. And this is how much we make as the profit of selling the next item, okay? Now, can we come up with a number where can we evaluate and see what happens? This one, class, you can calculate on your own and see that it's almost the same. So the cost for 51st unit is a C of 51 minus C of 50. In other words, you can go to this formula, plug in 51, and then we've already calculated 50 from the previous page. Their difference is almost the same. You can do the same thing for the revenue, R of 51 minus R of 50. For the profit, P of 51 minus P of 50, and you get these two numbers respectively. When I say these two numbers close to them, because that's an approximation, I highly recommend you do this on your own and compare. Okay, here's the last question. Can anybody read this last question for us, please? Anyone? Can somebody read this last question for us, please? Okay,
I can read it, Professor.
please.
Example 6. The height in inches of a sunflower X weeks after being planted can be approximated by the function f of x is equal to 6x minus 1/4 x squared. A. How tall is a sunflower 8 weeks after planting? B. Find the average rate of growth from the end of week 6 to the end of week 12, include proper units. C. Find the instantaneous rate of growth 10 weeks after planting, include proper units. D. Explain the meaning of your answer to part C.
Thank you so much, Zaina. The first part is very straightforward. You have the function plug in 8. And the units, the height in what? Take a look in inches. So you got to pay attention to the units always when you do word problems. The next one, the average rate of growth. Okay. The total growth over the course of 6 to 12 weeks over the total time. So this is the formula that is used, the average. So f of 12 minus f of 6 over 12 minus 6. And you plug in number 12, you plug in number 6, and the denominator is 12 minus 6. As far as the units, I hope everybody realized the units of the numerator, okay, change in height in inches over the units of the denominator, changing time in weeks. So that's why you got to pay attention when you come up with the proper units. The second part does the differentiation because it says instantaneous, even if it doesn't, because one point in time. So 6 minus 1/4 times 2, which is minus 1/2 x. Now plug in 10 and evaluate it, and you get 6 times 6 minus 1/2 times 10, which is 5, 6 minus 5, which is 1, and the same units, class. The units for the average growth and the instantaneous growth, the units are the same. The units are the same. So what does it mean? And that's important to do and understand the interpretation. On or after week 10, the sunflower is growing at a rate of 1 inch per week.